Hello student, welcome to the lecture on nutrition, and after this lecture we will be able to learn the following objectives. Understand the components of physical fitness, describe human nutrition and functional anatomy, explain the nutritional biochemistry, describe nutrition during particular times in the life cycle, pregnancy, lactation, infancy, childhood and old age, explain the malnutrition, obesity and iron deficiency. Let's start with the introduction. Nutrition, nourishment or element is the supply of materials, food required by organism and cells to stay alive. In science and human medicine, nutrition is the science or practice of consuming and utilizing foods. In hospital, nutrition may refer to the food requirements of patient, including nutritional solution delivered via and for intravenous or IG intragastric tube. Nutritional science studies how the body breaks food down, catabolism, and repairs and creates cells and tissue anabolism. Catabolism and anabolism equal to metabolism. Nutritional science also examines how the body responds to the food.
Every day, Hari and Ravi sit down to have their meals. Ravi eats ragi mudde, sambar and a lot of green vegetables. Whereas Hari doesn't have the food he is served. Hari only wants to eat oily biscuits and cakes from the shop. Ravi was growing up to be a strong and healthy boy, but Hari looked weak and unhealthy. Whenever they used to climb the tree, Ravi would climb up very easily. But for Hari, it would take a lot of effort to do the same. One day, Ravi and Hari were sitting in the park. It suddenly started raining, so they both got up and started running back home. Ravi started gaining speed. All those nutritious food in his stomach started giving him energy to run faster. His legs were strong enough to swiftly carry him home. Hari, on the other hand, started sweating and panting. He had difficulty in keeping up with Ravi. He had nothing nutritious in his stomach to give him energy. His legs couldn't hold him up, and he fell down on a puddle and bruised himself. When he finally reached home, he was all drenched and was in pain. Later that night, Hari had a bad fever because he got drenched in the rain. He silently made a promise to eat well and nutritious food like Ravi.
Let us discuss components of physical fitness. The 5 components of physical fitness are used in schools, gyms and health clubs to measure the level of physical fitness. Total fitness is defined by how well the body performs in each of 5 categories. Here is what one would know about the 5 components of physical fitness. The 5 components of physical fitness are cardiovascular endurance, muscular strength, muscle endurance, flexibility and body composition. Cardiovascular endurance refers to the ability of heart and lungs to work together to fuel the body with oxygen. Muscle strength refers to the amount of force a muscle can exert in a single effort. Muscle endurance refers to the ability of a muscle to perform a continuous effort without fatigue. Flexibility refers to the ability of each joint to express its full range of motion. Body composition refers to the amount of body fat we have versus the amount of lean muscles, bones and organs. Improving individual components. Once one has had one's own 5 components of physical fitness measured, one can use this information to form a fitness regimen tailored to one's needs. If one is weak in cardiovascular endurance, one will need aerobic conditioning in the form of jogging, swimming, cycling or even sports. Let us now discuss human nutrition. Human nutrition, process by which substances in food are transformed into body tissues and provide energy for the full range of physical and mental activities that make up human life. Begin by providing some information about the importance of nutrients in the diet. Carbohydrates. Carbohydrates are called carbohydrates because the carbon, oxygen and hydrogen they contain are generally in proportions to form water with the general formula CnH2ON. There are four major classes of biomolecules: carbohydrates, proteins, nucleotides and lipids. The four major classes of biomolecules are carbohydrates, saccharides. Molecules consist of carbon, hydrogen and oxygen atoms, a major food source and a key form of energy for most organisms. Lipids, fats. Molecules consist of carbon, hydrogen and oxygen atoms, the main constituents of all membranes in all cells, cells walls, food storage molecules, intermediaries in signaling pathways, vitamins A, D, E and K, cholesterol. Proteins. Molecules contain nitrogen, carbon, hydrogen and oxygen. They act as biological catalysts, enzymes, form structural parts of organism, participate in cell signal and recognition factors, and act as molecules of immunity. Nucleic acid, nucleotides, DNA, deoxyribonucleic acid, and RNA, ribonucleic acid. These molecules are involved in genetic information as well as forming structures within cells. Carbohydrates and nutrition. Bread, pasta, beans, potatoes, grain, rice and cereals are carbohydrate-rich food. Most carbohydrate-rich foods have high starch content. Proteins and fats require more water for digestion than carbohydrates. Carbohydrates are the most common source of energy for most organisms and animals, including humans. Fat. For years, nutritionists and doctors have preached that a low-fat diet is the key to losing weight, managing cholesterol and preventing health problems. But more than just the amount of fat, it is the types of fat we eat that really matter. Bad fats increase cholesterol and risk of certain diseases, while good fats protect heart and support overall health. Making sense of dietary fat. A walk down the grocery aisles will confirm our obsessions with low-fat foods. We are bombarded with supposedly guilt-free options: baked potato chips, fat-free ice cream, low-fat candies, cookies and cakes. Types of dietary fat. Good fats versus bad fats. To understand good and bad fats, one needs to know the names of the players and some information about them. There are four major types of fats: monounsaturated fats, polyunsaturated fats, saturated fats, trans fats. General guidelines for choosing healthy fats. Try to eliminate trans fat from diet. Check food labels for trans fats. Avoiding commercially baked goods goes a long way. Also limit fast food. Limit the intake of saturated fats by cutting back on red meat and full-fat dairy foods. Try replacing red meat with beans, nuts, poultry and fish whenever possible, and switching from whole milk and other full-fat dairy foods to lower-fat versions. Eat omega-3 fats every day. Good sources include fish, walnuts, ground flax, seeds, flaxseed oil, canola oil and soybean oil. How much fat is too much? How much fat is too much depends on lifestyle, weight, age, and most importantly, the state of our health. Keep total fat intact to 20 to 35% of calories. Limit saturated fats to less than 10% of calories, 200 calories for a 2000 calorie diet. Limit trans fat to 1% of calories, 2 grams per day for a 2000 calories diet. Eliminate trans fat from diet. A trans fat is a normal fat molecule that has been twisted and deformed during a process called hydrogenation. During this process, liquid vegetable oil is heated and combined with hydrogen gas. Sources of trans fat. Many people think of margarine when they picture trans fat, and it is true that some margarines are loaded with them. However, the primary source of trans fats in the diet comes from commercially prepared baked goods and snack foods. Baked goods, cookies, crackers, cakes, muffins, pie crust, pizza dough and some breads like hamburger buns. fried foods, donuts, French fries, fried chicken, chicken nuggets, and hard taco shells. Snack foods, potato, corn, and tortilla chips, candy, packaged or microwave popcorn. Solid fats, stick margarine, and semi-solid vegetable shortening. Pre-mixed products, cake mix, pancake mix, and chocolate drink mix. Proteins. Proteins are large, complex molecules that play many critical roles in the body. They do most of the work in cells and are required for the structure, function, and regulation of the body's tissues and organs. Protein in diet. Proteins are the building blocks of life. The body needs protein to repair and maintain itself. The basic structure of protein is a chain of amino acids. Function. Every cell in the human body contains protein. It is a major part of the skin, muscles, organs, and glands. Protein is also found in all body fluids except bile and urine. Food sources. When proteins are digested, amino acids are left. Amino acids needs to be eaten in large enough amounts for optimal health. Side effects. A diet high in meat can contribute to high cholesterol levels or other diseases such as gout. A high protein diet may also put a strain on the kidneys. Recommendation. A nutritionally balanced diet provides enough protein. Healthy people rarely need protein supplements. Vegetarians are able to get enough essential amino by eating a variety of plant proteins. Vitamins. The term vitamin is used to describe certain organic compounds that are needed by the body but that cannot be manufactured by the body. They mainly serve as catalysts for certain reaction in the body. If these catalysts are missing, as in a vitamin deficiency, normal body functions can break down and make a person more susceptible to disease. Minerals. A mineral can be defined as a naturally occurring inorganic solid that possesses an orderly internal structure and a definite chemical composition. Some people, like physicists, might be guilty of picking up a rock and calling it a mineral. The term rock is less specific, referring to any solid mass of mineral or mineral-like material. Common rocks are often made up of crystal of several kinds of minerals. Water. One of the benefits of drinking water is that adequate hydration has a huge impact on the immune system. Water helps all of our body system function at optimum levels. Drinking plenty of water flushes toxins and ensures that cells get all of the oxygen they need to function as they were meant to. Here is how drinking water affects the immune system. Water oxygenates our blood and flushes toxin. Water helps in the production of lymph. Water keeps eyes and mouth clean. Water helps to digest our food. Water prevents and treats common chronic ailments. Let us now discuss another topic, functional anatomy. When someone says abs, the first thing that comes to mind for many people is a six-pack. For many, including fitness clients, the abdomen has been marginalized to include just one muscle, the rectus abdominis. However, the abdominal region is composed of several key muscles that contribute to core function. The abdomen is the region lying between the proximal chest and the distal pelvis. This region is served by several muscles that contribute to spine stability in a variety of posture, providing the ability to flex, side bend, and rotate the trunk. Rectus abdominis. The rectus abdominis RA, the muscle made famous in movies and television, provides both core stability and trunk mobility. The RA is a trunk flexor. This muscle arises from the xiphoid process and adjacent costal cartilages, and it attaches distally into the pubic bone at the crest and symphysis. Transversus abdominis. The transversus abdominis TA is the deepest of the three flat abdominal muscle. The TA originates from the lower six costal cartilages, the thoracolumbar fascia and the ilia crest. This muscle attaches medically at the lineabula. Obliques. The external and internal oblique muscles rotate and side bends the trunk. These muscles also contribute to spinal stability. The external oblique is the most superficial muscles of the three flat abdominal muscles, the external oblique, internal oblique, and transversus abdominis. The internal oblique originates from the thoracolumbar fascia, the inguinal ligament, and the anterior iliac crest.
The rectus abdominis muscle is a long, flat muscle It is a paired muscle separated in the midline by the linea alba. Along its length, the muscle thickens and thins. You can see at the thinned parts of the muscle a tendinous intersection, and there may be up to 4 of these tendinous intersections. The origin of this muscle is on the pubic tubercle, the pubic crest, and the pubic symphysis. The muscle inserts on the costal cartilages of ribs number 5 to 8 and on the xiphoid process, which is about right over here. The action of this muscle includes compressing the abdominal contents, flexing the vertebral column, and tensing the abdominal wall. On this model, you can see the external oblique on this side of the model. It is not present on the opposite side. The external oblique is the most superficial of 3 flat muscles of the anterior lateral wall. The external oblique has an origin on the outer surfaces of the lower 8 ribs and inserts on the lateral lip of the iliac crest and the aponeurosis, which extends all the way to the linea alba. This muscle compresses the abdominal contents. Both muscles together flexes the trunk, and each muscle by itself bends the trunk to the same side and turns the anterior part of the abdomen to the opposite side. Most of the fibers of the internal oblique pass in the superior-medial direction. This muscle has an origin on the thoracolumbar fascia and the iliac crest over here and the lateral 2/3 of the inguinal ligament. It inserts on the inferior borders of the lower 4 ribs, the aponeurosis that ends at the linea alba, pubic crest, and pectineal line. This muscle compresses the abdominal contents. Both muscles together flexes the trunk, and each muscle by itself bends the trunk to the same side and turns the anterior part of the abdomen to the opposite side. The transversus abdominis muscle derives its name from the direction of the fibers, and you can see how they're crossing horizontally. The muscle has an origin on the thoracolumbar fascia, medial lip of the iliac crest, lateral 1/3 of the inguinal ligament, and costal cartilages of the lower 6 ribs. This muscle inserts on the aponeurosis that ends at the linea alba and the pubic crest and the pectineal line. This muscle compresses the abdominal contents.
Nutritional biochemistry. Nutritional biochemistry is the study of nutrition as a science, while nutritional science is composed of various studies in food, components, nutrients and their function regarding humans and other mammals. Nutritional biochemistry specifically focuses on nutrient chemical components and how they function metabolically, physiologically, and biochemically. Biochemistry research in this field is primarily centered upon defining dietary regulation for the general public. Malnutrition is typically a serious concern for a nutritional biochemist. It is often the cause of disabilities, disease, and other problems due to nutritional deficiencies or overnutrition. Genetics are also commonly studied by nutritional biochemists. Many diseases and dietary factors are affected by genetics. Biochemists can use genetic studies to pinpoint these different effects and improve public health overall. Core knowledge that defines nutritional biochemistry: structure and function of nutrients and other dietary constituents, chemical structure and metabolic functions of essential and non-essential nutrients, physiology and biochemical basic for nutrient requirements, motives of absorption and transport of nutrients, integration, coordination and regulation of macro and micronutrient metabolism, regulation of nutrient metabolism and nutritional needs by hormones and growth factors, interaction of nutrients with the genome, nutrient control of gene expression, DNA stability, dietary bioactive components, functional foods, non-traditional roles of nutrients, food, diets and supplements, food sources of nutrients and factors affecting nutrient bioavailability, effect of food processing and handling on nutrient content and bioavailability, nutritional toxicology, upper limits of intake, nutrient and drug, nutrient interaction, dietary reference intakes, DRIs, food guide pyramid, nutrient supplements risk, benefits, life stage, bioavailability, molecular markers of nutrient intake, gene arrays and analytical chips, nutrition and disease, impact of disease and genetics on nutrient functions and requirements, genetic basic of inherited metabolic disease. Food. Food is defined as a substance that can be metabolized by an organism to give energy and build tissue, any solid substance, as opposed to liquid that is used as a source of nourishment. Nutrition. Nutrition is the taking in and use of food and other nourishing material by the body. It is a process by which living creatures obtain energy from food and drink for the purpose of body growth and maintenance. Food groups. Foods may be broadly classified into 11 groups based on their nutritive value as cereals and millets, pulses, legumes, nuts and oilseeds, vegetables, fruits, milk and milk products, eggs, meat, fish and other animal foods, fats and oils, sugar and other carbohydrate foods, and spices and condiments. Nutrition during particular times in the life cycle: pregnancy, lactation, infancy, childhood and old age. Nutrient requirements differ to some extent at different periods in the life cycle. Females of reproductive age have extra needs because of menstruation and of course during pregnancy and lactation. Infants and children have greater requirements on a unit weight basis than adults, mainly because they are growing. Older people are also a vulnerable group. They are at greater risk of malnutrition than younger adults. Women of reproductive age, women of childbearing age have certain nutritional needs above those of adult males. One reason is that the loss of blood during menstruation leads to a regular loss of iron and other nutrients and makes women more prone than men to anemia. Pregnant women. During pregnancy, a woman's nutritional needs become greater, shall at other times in her life. Her diet needs to provide all the elements needed for the growth of a fertilized ovum or egg into a viable fetus and baby. As a woman nourishes herself, she also nourishes the growing fetus as well as the placenta to which the fetus in her uterus is attached by its umbilical cord. At the same time, her breast tissue prepares for lactation. Lactating mothers. In most developing countries, the majority of women breastfeed their newborn infants for a period of weeks or months after delivery. The nutritional stores of a lactating woman may already be more or less depleted as a result of the pregnancy and the loss of blood during childbirth. Lactation raises nutrient needs, mainly because of the loss of nutrients first through colostrum and then through breast milk. Infants and preschool age children. Provided that the mother has adequate breast milk, breastfeeding along with no added food or medicinal supplementation is all that is needed for the normal infant during the first 6 months of life. Exclusive breastfeeding means that not even water, juice or other fluids are provided. None of these are needed. The infant should be examined regularly at the clinic where weight gain is seen to indicate adequate nutrition. School age children. The vast majority of school children in developing countries attend primary schools. Most are at day schools, few of which provide a midday meal. In rural areas, the school is often some kilometers from the parents' home. The child frequently has to leave home early and walk a considerable distance to school. Food before going to school. It is not practical for many mothers to rise before dawn to spend the considerable time necessary to light a fire and prepare a hot meal for children before school time. Therefore, if no hot breakfast is available, some fruit, cold cooked potatoes, rice, cassava or even cold porridge should be left over from the previous day for the school child to eat before leaving home in the morning. Food eaten at school. This may consist of a midday school meal or a snack taken to school. A midday school meal is the ideal. It should provide reasonable amounts of the nutrients most likely to be missing or short in the home diet. A whole grain cereal as a basic and a side dish of legumes with vegetables or green leaves make an excellent school meal. Malnutrition. Malnutrition occurs when the body does not get enough nutrients. This can mean not getting enough food overall, which can lead to starvation, or can be the lack of a single nutrient such as vitamin C deficiency, which can lead to scurvy. Causes of malnutrition include not having enough food to eat, not being able to eat a balanced diet, having medical problems that prevent food from being absorbed properly, or having psychological problems such as anorexia nervosa. Symptoms of malnutrition. Malnutrition is a condition in which a person's body does not get enough calories or nutrients to keep it functioning properly. Symptoms of malnutrition can vary widely but include weakness, poor immune system functionality, and the inability to heal. Obesity. Obesity is one of the major medical problems. The clinical definition of obesity is a body mass index (BMI) of 30 or higher. The BMI is the body's weight in kilograms divided by the square of the body's height in meters. Obesity results when a person ingests more calories than he or she can burn off. If this happens regularly over a period of time, the body will store the extra calories as fat. The body is able to burn off calories as energy needed throughout the day, but if the energy is not burned away, it will be stored as fat. Causes of childhood obesity. The causes of childhood obesity are usually related to lifestyle choices, although they may also be caused by biological or genetic factors. Lack of exercise and poor diet are the most common causes of this condition. Childhood obesity can lead to a multitude of other health problems in children, including such conditions as high blood pressure, high cholesterol, and diabetes. Effects of obesity. The effects of obesity are numerous and daunting, and this is a condition few people choose willingly. Nevertheless, in many industrialized societies, it has become or is developing into a serious problem, and there are numerous countries assisted by medical experts seeking to stem the tide with government awareness programs. Iron deficiency. Iron is a mineral needed by our bodies. Iron is a part of all cells and does many things in our bodies. For example, iron as part of the protein hemoglobin carries oxygen from our lungs throughout our bodies. Having too little hemoglobin is called anemia. Iron also helps our muscles store and use oxygen. Iron is a part of many enzymes and is used in many cell functions. Enzymes help our bodies digest foods and also help with many other important reactions that occur within our bodies. When our bodies do not have enough iron, many parts of our bodies are affected. Causes of iron deficiency. Iron deficiency has many causes. These causes fall into two main categories. Increased iron needs. Many common conditions can cause people to need additional iron. Because of their rapid growth, infants and toddlers need more iron than other children. Sometimes it can be hard for them to get enough iron from their normal diet. Women who are pregnant have higher iron needs. To get enough, most women must take an iron supplement as recommended by their healthcare provider. Decreased iron intake or absorption. Not enough iron taken into the body. The amount of iron absorbed from the diet depends on many factors. Iron from meat, poultry, and fish is absorbed 2 to 3 times more efficiently than iron from plants. The amount of iron absorbed from plant foods depends on the other types of foods eaten at the same meal. Most at risk. Young children and pregnant women are at high risk of iron deficiency because of rapid growth and higher iron needs. Adolescent girls and women of childbearing age are at risk due to menstruation. Among children, iron deficiency is seen most often between 6 months and 3 years of age due to rapid growth and inadequate intake of dietary iron. Signs and symptoms of iron deficiency. Too little iron can impair body functions, but most physical signs and symptoms do not show us unless iron deficiency anemia occurs. Someone with early stages of iron deficiency may have no signs or symptoms. Signs of iron deficiency anemia include feeling tired and weak, decreased work and school performance, slow cognitive and social development during childhood, difficulty maintaining body temperature. How is iron deficiency detected? The doctor or healthcare provider will do blood tests to screen for iron deficiency. No single test is used to diagnose iron deficiency. The most common tests for screening are hemoglobin tests, a test that measures hemoglobin, which is a protein in the blood that carries oxygen. TORCRIT test, the percentage of red blood cells in the blood by volume. These tests show how much iron is in the body. Hemoglobin and TORCRIT levels usually are not decreased until the later stages of iron deficiency, that is anemia. What can we do to prevent iron deficiency? In general, we can eat a healthful diet that includes good sources of iron. A healthful diet includes fruits, vegetables, whole grains, fat-free or non-fat milk and milk products, lean meats, fish, dry beans, eggs, nuts, and is low in saturated fat, trans fats, cholesterol, salt, and added sugars. How much iron do we need? If we have already been diagnosed with iron deficiency, talk to a doctor or a healthcare provider about treatment. Now, in the end, let us summarize what we have learned in this lecture. Someone with early stages of iron deficiency have no signs or symptoms. Iron is a part of many enzymes and is used in many cells' function. Television viewing often goes hand in hand with snacking on empty calories, another of the primary causes of childhood obesity. Obesity is usually caused by a poor diet and lack of exercise, but there are some medical causes for the problem. Malnutrition is a condition in which a person's body does not get enough calories or nutrients to keep it functioning properly. Iron is a part of many enzymes and is used in many cell functions. Enzymes help our bodies digest food and also help with many other important reactions that occur within our bodies. When our bodies do not have enough iron, many parts of our bodies are affected. Iron deficiency is a condition resulting from too little iron in the body. Iron deficiency is the most common nutritional deficiency and the leading cause of anemia.